Hello everyone, here is a question from electrochemistry. 2 ampere current is allowed to pass through molten AlCl3 for 30 minutes. Find the mass in milligrams of aluminum deposited at cathode. We need to find out the nearest integer. Here AlCl3 is undergoing electrolysis. This means that in the aqueous medium we will be having Al3+. Therefore, the half reaction happening at the cathode is reduction. Al3 plus gains 3 electrons and we will be getting Al solid. Cathode reduction. What this means is that if we have 1 mole of Al3 plus, we require 3 moles of electrons so that we can get 1 mole of aluminum. That is the stoichiometry here. Now, we need to calculate the mass of Al deposited at the cathode in milligrams. As per Faraday's first law of electrolysis, mass of the substance deposited or liberated at any electrode is directly proportional to the quantity of electricity or charge Q passed. Q is equal to current times time. Therefore, mass is proportional to current times time. To get rid of the proportionality factor, we introduce a constant called Z, that is the electrochemical equivalence. Therefore, mass is equal to Z times current times time. Now, Z is equal to equivalent mass divided by valency factor. Valency factor in this case is found as 3 and equivalent mass is equal to molar mass divided by Faraday constant. Therefore, mass is equal to molar mass times current times time divided by valency factor times Faraday constant. Therefore, this is equal to molar mass of aluminum is 27 gram per mole, current is 2 ampere, time is 30 minutes, but we need to convert it into seconds. Therefore, multiply by 60 divided by 3 times 96,500 coulomb per mole. Ampere second is coulomb. Therefore, coulomb we can cancel, per mole also we can cancel, 20 we can cancel here. So, this is 3 times, this is 9 times 3 is 27, therefore, this is 9. So, 9 times 2 18, 3 times 6 18, therefore, 18 times 18 is 324 divided by 965. That is what we need to find out, but the answer is going to be in grams, which we need to convert into milligrams. Therefore, 324 divided by 965, we can't divide it, so put as 0. 3 times will be 2895 and the remaining will be 5 here, 13 minus 9, that will be 4 and then 11 minus 8, 3. Once again we can't divide it, so put as 0. Again 3 times, so 2895 again, 5 here, 14 minus 9, therefore 5, 13 minus 8, 5. We can't divide once again, therefore put as 0 and then 5 times will be 4825 and then 5 here, 4 minus 2, 2 and then 15 minus 8, 7. Once again we can't divide, so put as 0. 7 times will be 6755. So, therefore, now we can write that mass is equal to 335.7 times 10 to the power minus 3 gram, which we can write it as 336 milligram. The aluminum deposited at the cathode is 336 milligrams. That is the correct answer. M is equal to 336 milligrams.